I'm gonna try that.
All right, I'd like to start the meeting, please. Boy, that worked.
I think we need to wait a little bit because traffic is very.
No, they'll get here. I mean, I don't know how long to wait when we're waiting, so try and be prompt. So welcome to CiNPA, everybody. My name's Alan Miller. I'm the president. I see mostly familiar faces, but we have someone I don't know. This man in the back, his first name is Dean. Make sure you say hi to him later. I hope you're not shy. Now that anyway, tonight we have Jason Hogue who's going to talk about AWS. Am I right so far?
Yeah, that sounds like
I'm not going to say anything more about it than that. People have been asking me what you're going to talk about, and I have general knowledge, and that's all. Anyway, there's a lot of information for Dean. Anybody that's new. Who are you?
I'm Joe. I'm a junior at Vpc End.
Oh, all right. Hi, Joe.
Joining us for the first time today.
Good. A lot of information on our website, CiNPA.org. We have mailing lists so you can sign up for them. We have a couple other subgroups, special interest groups, and they have other meetings during the month. And Kevin Royalty over here is in charge of one. Do you want to say anything about what's coming up?
I don't have my notes for what's coming up right now. I'll send that out.
Okay. So the thing to do if you want to keep up is just sign up on mailing lists. Anybody can sign up for those. Brad, do you want to say something?
Yeah. For those of you that don't know, I'm Brad Green, but we also have one that is a Linux-based FOSS free open source software group. We're meeting once a quarter, not on a regular spot yet. We're looking at the fourth Tuesday. However, I've had a request tonight to move that to the fourth Monday this month. So I'm going to aim at doing that. We're going to focus on Clear OS. This month is what I want to do. Also looking to have lively discussions around the Raspberry Pi 4 that just came out. Klaus is kind of an expert in that. If he's going to be there, you going to be able to attend, Klaus?
I'll see what I can.
Okay. As well as just any questions and ideas that come up from the group. But we are restarting this. And like I said, look for an email. There is a mailing list specifically for the OSS group or the Linux group on the website. Go ahead and add your name to that, and we'll get you communicated.
Thank you. Jan, you want to tell us what's coming up next month, please?
Well, I have decided here I'm introducing to Untitled networks, which is very interesting problem, and to Google. So it will be either Google presentation or Untitled networks. I do not want to give you more details. I know which I talked to them what I want to present. But it's one of two with a couple more options exist. But on the top list is either Google or Untitled networks.
Okay, thank you. Again, our mailing list will have announcements as the information is available. So without any more ado, I'll turn it over to Jason.
All right.
You got the floor.
Thank you. Everyone hear me okay? Is that too loud? I can talk softer. All right. So welcome to tonight's meeting. And if you don't like the way I present, you can blame Jan because he's the one that invited me. But I met Jan probably a year ago at the user group that we host for Amazon Web Services over at Max Training. Currently this year we're doing it every other month on the fourth Tuesday. So we'll have our next one, I think it's August 27th, if that's the fourth Tuesday of the month.
Actually, that's why we got the request to change mine. That was so they could amend yours.
Oh, well, we really appreciate that. I had no idea that we pushed you out. Yeah, my name is Jason Hogue. I am a solution architect with Amazon Web Services. Quick show of hands, how many here use Amazon Web Services? Okay. How many use it for their business or their company? And how many people, how many people have never touched it? right, so we got about half and half. All right. So I didn't have, a particular deep dive topic today. So what I'm really going to focus on is kind of an intro to AWS. For those that use AWS, some of this may be review. But the first half really focusing on kind of how you get started when you have, existing technology technology stacks, existing applications, and you want to move them to the cloud. What is, what is that best pattern to get there? So that'll be the first session, and then I guess after dinner we'll go into the second session, which will be really an AWS 101 primer. I may bring up the console, do a few demos, things like that, but we're really going to touch on the core services like Amazon Compute, which is EC2, storage, database, networking, and security. Any other topics that you guys are interested in?
If you can briefly touch on certifications.
Certs, okay. Is there anyone here that is certified in any of the AWS certifications?
I'm about to get certified.
Okay.
Didn't know there were AWS certifications.
All right, so I'll touch on that at the end. All right, so what is AWS? What is Amazon Web Services? So how many people use, if they don't use AWS, use the cloud in some fashion or form? Most everyone, right? It's connected to almost everything we do nowadays. But AWS, the goal there is really to provide highly reliable, scalable, low-cost infrastructure. We've been doing this since 2006, so over a decade of experience. And the benefits that our customers realize include things like lower cost. Now, I'll tell you from experience, if you just go and you spin up a server, similar to maybe one you have on-premise, you may find that, I'm not saving all that much cost. So that's really the journey that I want to talk about today, is how customers actually optimize operationally and technically to be able to save cost over time. The second is elasticity and agility. So this is the ability to move quick. So I've been in enterprises before where you have to procure hardware, storage 3 years in advance, know exactly what you're going to do in 3 years, and that's just not the way of the world today. Things change so quickly that it's, this idea of being elastic, being agile is so important to growing your business. Open and flexible, meaning that we have a lot of choices. We have over 160 services. Each of those services have hundreds, if not thousands of features. I think we release something along the lines of around 1,700 new features per year. So that comes out to roughly 3 to 4 new features every day. If you sign up for the AWS What's New RSS feed, you'll get a constant update every day of those new features that come out. And those new features could be anything from a new setting, a new configuration capability to help you automate, all the way up to a new region. So like just last week, we announced our 22nd region, which was in Bahrain. And then we have, I think, 3 more that have been announced that are in the works and will probably go live in 2020. But also, as far as being open, we have APIs for everything. And this is really where customers, enterprises, small businesses, startups really see the value in moving quickly because they can automate things through this concept of DevSecOps nowadays. You want to be able to make changes quickly, realize them in your application in test, make sure that it works, and then send it to production as quickly as possible. So those open APIs that are also secure are really tantamount to being able to perform those automated actions. And then secure. So AWS, and I'll have a whole section on security, but we'll talk about all of the options you have around security for securing your AWS environment. And then lastly is global reach. So how many people think it would be easy to spin up a data center in Ireland tomorrow, or spin up a data center in China in the next 2 weeks? Well, with AWS, you can actually get on board those regions just by going into the AWS console and launching your resources into those regions. little bit about what we believe sets AWS apart. The first thing is really experience. So Amazon in general, likes to move quickly. They have this concept of let's fail fast, figure out if it works. If it doesn't work, that's fine. If it does, then we move quickly and build something. And then we iterate and learn over time. And so that's really how AWS has jumped from what it was in 2006 to now over 160 services supporting enterprises around the globe. That service breadth and depth, as you can see here, this is actually outdated. It says 145. It's now around 160. Pace of innovation, so continuing to iterate. I mentioned those, 3 to 4 new changes every day. The global footprint, and then the pricing philosophy. I work with enterprises, specifically right now I'm working with R1 research universities in Ohio and Pennsylvania, and my goal is always to help them optimize how they're running their workloads, but a big part of that is cost, and optimizing cost and helping them to save money. And we at AWS feel that in order to keep customers, you have to continue to proactively make it more cost optimized to run in the cloud. And then the ecosystem is huge. Thousands of consulting and system integrator and technology partners. We have a marketplace. You can go in and purchase software using AWS as that vehicle to do the purchase. Great thing with that is you don't have to get into these negotiations necessarily with the vendor. They have their price points. You go and you purchase the software, you use it for as long as you need to, and then you can decommission it when you're done. I have like 200 slides, so I'm going to skip a few of these. Because I don't think you want to be here till midnight. I could definitely go till midnight. I've gone about 7 or 8 hours at a time. So, again, that pricing philosophy is really around this idea of trading capital expense for variable expense. So I mentioned this earlier. That I've been in companies where you have to procure that big capital expenditure based on what you think. A lot of times, just a hunch on what you need for the next 3 to 5 years. And now you're moving into a model that's more variable, and you can change your workload more quickly. It's also important to understand how that pricing model helps you optimize your cost over time. And so I'll talk a little bit about these guys, on-demand, reserved, and spot instances in a little bit. And lastly, Amazon as a whole, we have this idea of leadership principles. We have 12 leadership principles. One of them is customer obsession, and that starts from the top. And it's really, when it really comes to light in AWS because we listen to our customers. I actually collect a lot of feedback and send it over to the service teams and say, this customer is looking for this feature, or they'd like, this new service. And we get that in front of our service teams. And our service teams can operate quickly because they operate very much in what we call 2 pizza teams, meaning that team is about as large as what you need to feed a team with 2 pizzas. And so they can be very agile in how they operate, how they innovate, how they deploy new services and features. A little bit more on the global reach. So we have 22 regions now. I had to update this slide because it said 20 when I brought it up yesterday. But those 22 regions are really there for you to be able to run your workloads either closer to your users or to bring in redundancy, high availability across multiple regions, disaster recovery so that you have your data spread apart in the case of a disaster, or in the case of things like data sovereignty, being able to hold your data in specific regions. One of the things that AWS will not do is move your data unless you call a service API or something to actually do that. So when you go and you say, I'm going to spin up an EC2 instance with this disk drive in, for instance, Ireland, it's going to stay there unless you're the one that takes action and actually moves it or copies that data.
How Amazon decides on these regions? I see, for example, there's nothing in Africa and Middle East. I just want to know what the basic decision-making process.
It's mainly by customer feedback and understanding what is the priority of the customers. Africa is definitely one we've heard. And I believe we announced that as a coming region as well. So that's really where we get that is.
What you do with Israel is the hub, IT and IT security hub. It's the main part of the
Yeah.
So is there anything planned to around Middle East?
Yeah, so let me actually bring up the region table and then,
It's just strange to me.
yeah. I get that question a lot because, there's always certain use cases, and I can tell you that we definitely do listen to customers, understand where they want those regions.
So it's driven by customer demand or by financial, geographical, geopolitical situations and causes?
Yeah, it's, I'll tell you first and foremost by customer demand, but I'm sure there's other things that go into it that I'm not privy to.
Yeah.
Right. So there's our regions around the world. So you'll see here we have the coming soon ones. So that's in Cape Town, in Jakarta, and in Milan.
Well, I see Saudi Arabia as well, so it seems like
Yep. So we have Mumbai,
Mumbai is in India, but where?
Singapore,
Saudi Arabia.
and Bahrain,
Okay.
yeah, which was just launched last week. It was announced probably about a year ago and then just launched. And while I am here, I was going to bring this up a little bit later, but there's a website called infrastructure.aws. So if you want to drill into the regions and this concept of availability zones that we have within regions, you can do that. And so this is an interactive map that actually shows you how the regions are built, how they're connected through networking and so forth. Yeah, question?
Your competition, especially in the U.S., they say within a couple hours they'll have your data backed up, like to the Midwest or the West Coast. Where do you back your stuff up in case something happens and you need your data back?
Yeah, so that's a great question. So we have this concept of availability zones. Availability zones are within a region. So think of them as a collection of data centers within a region. But each of those availability zones are built on different power grids, different floodplains, different networking. So you get that high availability across it. And our services, when they're built, so like for instance, Amazon S3, your data is automatically copied across those availability zones to give you 11 nines of durability. And then additionally, some of our services, I mentioned like data sovereignty, we want to make sure that your data stays where you tell it to stay. But some of our services have the ability to do things like read replicas to other regions. They have the ability to do snapshots to other regions. They have the ability to do object or file object copies over to other regions as well. And that's something you can configure within the AWS environment.
Yeah.
And so this just breaks down exactly what that regional facilitation looks like. So again, the concept of a region is a geographic center, and then within that you have these availability zones. All of them have at least 2. Most of them have 3. Some of them, like our US East 1 region, which is in Northern Virginia, has at least 6 availability zones available to it. And there's the website that I mentioned, so you can take a look at the global infrastructure interactively within that. Yeah, if you have questions as we go through, let me know. So what I wanted to focus on now is like this concept of why and how would you move to the cloud. Some of the use cases that we see a lot is around business goals are growing new revenue streams. So, I have a new idea, a new project, a new concept. I want to launch it quickly. I can do that quickly and very agile in the cloud. Improve operational and financial efficiency. So the ability to scale up and scale down based on capacity and demand needs. And then third, lowering business risk. One thing I always say is go out and look at what some other customers are doing. So we have a full lineup of case studies out there, so you can take a look at specific case studies. And you can do that by industry, you can do that by solution. So if you're interested in maybe artificial intelligence and machine learning, you can go out to that website and view some of these case studies. I want to focus on 4 real quickly. And they kind of tie into those business goals that I talked about. So McDonald's, one of our case studies, they have a couple case studies out on their website. But this was one specific to growing a new revenue stream or creating a new project. So they basically were able to bring their home delivery to market in 4 months. So they were able to take advantage of things like serverless technology, AWS Lambda, API gateway, and so forth, to be able to build out this very quickly, test it out, and then move it to production. Ryanair, so they wanted to deliver a very personalized portal for their travelers. So they took advantage of machine learning within AWS. AWS has a service called Amazon SageMaker, which was pretty groundbreaking when we announced it, because not only did it give you machine images that were already optimized and installed with the most popular frameworks like MXNet and TensorFlow, but it also gives you a pipeline of helping you develop machine learning models. It gives you starting points, so you don't have to start from scratch. So if you have a use case in mind, whether it's image recognition or natural language processing, you can quickly get started and then bring in your own data and do the training on Amazon SageMaker, and then actually deploy directly from SageMaker an inference endpoint, so the ability to then either make recommendations or make decisions in real time or batch. And then GE Healthcare, was, so their use case specifically was around creating a new digital business. And they mentioned there they chose AWS for the breadth of services and the compliance capabilities. So we have over 35 compliance capabilities within the platform. Talk about that a little bit more in depth in the second session. And then lastly, Mint.com. So they made the concept or the comment that data center management was not their core business, and they wanted to now focus more on delivering those exceptional financial management products to their end users, and less on managing the back-end IT environment. Any questions so far? All right, so we'll go a little bit deeper into how to reach those business goals and some of the trends, some of the best practices that we see from enterprises. So that first is around migrating and freeing up resources. So how does this happen? There's really 4 points and 4 goals that you want when you migrate and free up resources. So first is reducing costs, right? You want to reduce infrastructure costs. Second, use existing staff for higher value work. Do we have any database administrators in the room? Okay. Got one back there. I used to play one on TV, but I was never really one. But how much time do you spend worrying about am I going to run out of storage? Is everything patched correctly? Do I have the latest version of the database engine? It's just a lot of heavy lifting, and so what we found is that DBAs have plenty to do without all that. So we'll talk a little bit later about our managed relational database service, which takes a lot of the heavy lifting and allows them to focus on actually helping their application, helping their business to run more efficiently. Creating momentum to grow new skills and processes. What we see is people get into the cloud and they start to realize, oh, I can do more, I can learn more. And so they get that momentum, and then inventing and iterating with flexible resources. So how do you save cost? How do you actually optimize? So it's not like day one I just flip the switch and everything's optimized, right? There's typically a path or a journey. So let's say you're running on a server, a couple servers with a load balancer or whatever it may be. A lot of times, the first thing you do is lift and shift. Lift and shift is basically I take my existing infrastructure and I bring it into AWS, running maybe like for like, as to what I was doing on premise. But once you bring it in, and there may be a small reduction of total cost of ownership there, because you do get some things. You get the ability to, first of all, right size. So in your on-prem environment, you may not have that flexibility to kind of on demand reduce the capacity that you actually need and run closer to it, because you've made an investment for 2, 3, 5 years based on what you think you're going to need. So now with AWS, you can right size. You can change the instance types, change the instance size, and actually run at a lower capacity based on your actual demand. And then as you go through, you'll see doing things like improved elasticity, being able to horizontally scale your fleet of servers instead of vertically scaling. And then over time, you iterate. So you measure through one of our services called CloudWatch. You look at those metrics and you say, okay, I'm running at 20% capacity on my CPU. I think I can continue to right size these. Or maybe it's, I'm running 80% capacity from 9 to 5, and then 10% capacity overnight, right? So that's where things like auto scaling come into play. So you can actually horizontally scale your fleet of servers based on that changing demand over the day. And then it just continues, so you can do things like optimizing the type of instance that you choose, maybe based on compute or memory, storage optimization, so choosing the right type of storage and maybe less expensive. And then we get into things like serverless architectures, where there is a re-architecture, but take for instance a server that maybe you set up for APIs, for hosting APIs. So now you can basically take that same code, move it to a serverless architecture using like an API gateway and Lambda, which is our serverless functions. Put that together, and not only are you saving costs, but you automatically get scaling within that system. And then people a lot of times then move to a managed service like our relational database service, API gateway, and things like that. So to get a true TCO comparison, you got to kind of look ahead, look into that future, and have that journey kind of laid out of how do I want to get to a fully cost-optimized cloud experience.
Abbreviations, maybe some people don't know. So when we say TCO,
so TCO is just total cost of ownership. I'll start to explain those. But we always say that because you have to look at not only dollars and cents, but you also have to look at the time that people are saving, the time to market for your products and businesses and things like that. And eventually you want to get to business outcomes. I highlighted 4 here, but those business outcomes could be consolidating data centers. It's kind of crazy that people have 50 plus data centers, 90 plus data centers, whatever it is, and they may have grown over time just based on acquisitions and things like that. Now they're consolidating them, but they're also using that as a time to also reevaluate their journey to the cloud and think about, okay, how can I consolidate on-prem, but also how can I start to move and migrate some of my applications to the cloud. And then you see there, in this case, reducing time to market for new features. And then here, unlimited data growth. It's not uncommon nowadays to hear, the words petabyte and exabyte, where, terabytes used to scare us, and now terabytes no big deal when you have that unlimited data growth within AWS. Second thing, so modernizing your application development practices. And this really, supports the idea of moving quickly over time. So if anyone's supported like big monolithic applications, these are things where, you have different people making changes and there's a big build like every 3 months, every 6 months. People still do this. And what you really lose there is agility, the ability to make changes more quickly. And so this idea of moving to microservices has been pretty popular for a while, and we support that with a lot of our services, like I mentioned API gateway and things like that. So you can start to break out your monolithic application into those services. Faster, deeper insights. Anyone here play or experiment with like machine learning technologies? So we got one over there. How about data analytics? So Hadoop, large, big data, things like that. Okay, so we got a couple of those. So that could be really hard to do at scale and efficiently. A lot of times with hardware that you have on premise, because you're always limited to what you currently have. And you may say, man, if I only had, a couple more servers for, another 48 hours, I could do this. I could run this machine learning job, or I could run this analytical job, in 70% less time than I'm doing now. And on-prem, that's hard to do, right? Because you have to go through procurement and all this stuff. You have to have the capital to actually outlay. So this idea of gaining deeper insights is really important in AWS, because now you have that scale of the cloud. You can use it as needed and then retract it back when you're done. IDC has had a survey out that said 40% of digital transformation initiatives will be supported by AI in 2019. AI itself is kind of a broader superset of machine learning, but this is very important because people want to understand, how to maybe how their customers are acting and how they can better serve their customers, or how they can be more secure by looking at data that's coming into their web logs and their access logs and things like that. So this idea of putting AI to work for your business, really important. We have a lot of customer stories on this, so you can view those on our website. You'll see like SageMaker start to pop up a lot in those case studies. So again, this idea of accelerating the analysis of your data. And we know that data collection is not slowing down. You're going to get more and more. So being prepared for that future is really important. There's another quick one I wanted to highlight, because I met the guy that helped with the project. I briefly touched on it, but we have different pricing models. We have on-demand, so this is basically, you go onto our pricing sheet, you'll see, this is how much this certain instance type costs per hour. We have reserved instances, which basically says, okay, I know I'm going to need, this capacity for the next year, so you can purchase a reserved instance and typically get a pretty heavy discount, anywhere up to 70%. And then we have this idea of spot instances. So this is where you're basically using our unused capacity. So this allows you to get those instances at up to 90% discount. And this case study is pretty cool because, so this was a natural language processing, so a machine learning algorithm that Clemson University ran. They actually used 1.1 million CPUs on EC2 Spot. And they were able to run this natural language processing algorithm in about 36 hours using EC2 Spot at very low cost, compared to what they would have to do and how long it would take if they had done this with their existing supercomputer capacity. So a really, really good case. And this shows, their architecture. So they were able to use a lot of their existing tools. So you see here Slurm for their HPC scheduler and things like that, but then they were also able to take advantage of like Amazon S3 for the data storage, and then EC2 for the auto-scaling spot fleet. All right, next, as far as goals, ensuring security and resiliency. So when it comes to security, AWS has controls in place. We have this idea of a shared responsibility model. So that basically means that AWS, when you look at like, EC2, which is our computer offering, is responsible for hypervisor down, and the customer is responsible for everything up. Now over time, we've heard from customers, well, we want you to take more action for us. So like if you look at like RDS, we manage the operating system, the database engine for you, and then you have controls over like when you want to do patching and things like that. And then over time, and I'll talk about this in the next session, but over time we've also introduced a lot of different detective controls to help customers, as long as they turn them on, to help them detect abnormalities. We have a service called Guard Duty, which actually it looks at 3 different types of logs, and then based on that, it has an algorithm that will detect intrusions, we'll say suspicious activity, things like Bitcoin mining and things like that, and then alert the account owners when those occur. And then being able to scale globally. So this is important again for especially large enterprises that maybe have acquisitions where they're acquiring companies maybe in different regions around the world, and they want to migrate off of old data centers that are there, but they still want to have that data locality in those specific regions. And then not to be forgotten is how you organize your business, your teams, etc. You want to start to think about how you organize for speed and agility in your teams. I've gone through with customers through what we call migration planning, and part of that is always about, it's not just technology, it's always about process and people. So making sure that you have processes in place that will support a more agile method. And that could be everything from your application development process to how you provision resources. So there's not, once you get to the cloud, there's typically not a long cycle that you need to provision EC2 instances because it's at the click of a button, and that's what people expect. They want those more agile functions within AWS. And then lastly is bridging skills and experience gaps. AWS and the cloud, it's new. There's new concepts. And so this is an interesting slide because it talks about people really want to get to the cloud. This survey specifically says 88% of enterprises have a cloud-first strategy. But if you look to the right, 86% still spend money on on-premise infrastructure. And a lot of that is driven by the fact that the biggest inhibitor to that cloud adoption is lack of skills. I don't have the right skill set. I don't have the right training for my people, and that's where things like certifications and training are really important to understand that there is new skill sets that typically need to be learned within the cloud and within Amazon Web Services.
Do you have statistics for if you what percentage of your customers, Amazon AWS customers, are fully in cloud, and which ones are employing hybrid environments? Does Amazon know?
I don't know. So the question was, what percentage of customers are all in? All in on the cloud. Which ones are hybrid? Which ones are kind of still thinking about it? So I don't have percentages on that. I can tell from my customer base that there is a cloud first strategy, but they're going to be operating hybrid for a while because they have a lot of this in their institution. Lack of skill set, old legacy systems, and things like that. Now, I do have customers where parts of their organizations fully moving to the cloud, moving out of their data centers. We have within our case studies, we have several customers that are all in on AWS. We have some customers that never had data centers. So you look at startups like Slack and Robinhood and things like that. They started in the cloud, and so that's where they are.
Yeah, I understand. I'm talking about those existing who do have data centers and decide just make business decisions to move partially or fully cloud. I don't have any customers who fully cloud. I do have a few of them who I actually push them. Not in Amazon, but now we start in Amazon.
Yeah.
But all of my clients who have cloud are clients. And these are, to me, are these reasons
which I would love to get your time and discuss the subject why. That's why I asked if you know. And if Amazon sees this time, then everything will be involved.
Well, yeah, I will say that in the fullness of time, we do believe that people are going to stop building data centers. Yeah, I mean, it makes so much sense from all those things that we've gone through, not only financially, but also just total cost of ownership. Now, we can't predict the future in 20 years, but we do believe that that's the trend that we see with everyone is that cloud-first strategy. But the hybrid model is going to be there for some time. All right. So again, AWS is there to help you kind of enable that move to the cloud. So learning those technical skills is important. So we have a lot of web content, a lot of online training, a lot of in-person training. We have the user group every 2 months. If you guys want to come and ask questions, we have solution architects from around the area that typically attend and present at that. But again, these are kind of the pillars to how do I start to get into the cloud? How do I start to move my applications? How do I start to train my people for that? And this is kind of the cloud journey that we often see. So a lot of times it starts small, starts with a project. So you saw, for instance, the McDonald's case study. It was around a specific project, home delivery. But there's other things that follow typically after that project. If you have a successful project, then you start to take some of those foundational components, start to move them to the cloud. You go through a migration planning session and then a migration journey. And then a lot of times people are modernizing as they go to the cloud. Sometimes they modernize after they come to the cloud. And then just continuously reinvent their applications and their technology within AWS. All right, so how are we on time? It's 7:43.
Okay.
Okay. When should I break?
When do you start seeing people smelling pizza?
Pizza? Okay. All right. So we'll dive a little bit deeper into why you would build on AWS, a little bit on the how as well. So the first thing we want to talk about is the compute platform of AWS. So this is continuous innovation that's come over the last 13 years of AWS being in existence. If you look at EC2 in 2006, quite different than it is in 2019. And what we've done is really try to build a service with features that will support virtually every workload. Everything from the smallest microservice up to the largest ERP systems. So I'll go through each of these, but the first thing I'm going to talk about is having that broad and deep platform choice. So when we talk about compute, it used to be just virtual machines, right? So this is Amazon EC2, which is virtual server instances within the cloud. So when we say an instance, that's a virtual machine that you provision within your account. But we also know that people are starting to basically virtualize virtual machines, right, with this idea of Docker and containers. And so we have several options for that. Amazon ECS, which is our Elastic Container Service, so it's container orchestration. EKS, which is specifically container orchestration for the Kubernetes platform. And then Fargate, which think of that as kind of a managed service for container orchestration. Think of it as I have a container, I want to run it, I'm going to send it to Fargate, it's going to take care of auto-scaling and everything for me. And then lastly, yes? Question?
Could you explain container for the dummy that doesn't know what container is in this case?
Yeah. So the way I like to explain it is you think of the old world, you had physical servers, right? So you had physical servers, you run an application, you run it on the server. And then we went into virtualization. So you had virtualized technologies, VMware, and so forth. So now you're taking all those resources on the server and you're breaking it up and you're making it more efficient. Think of a container is now you're taking that virtual machine and now you're breaking that up into images. And those images, it's typically a small OS. And so you can run containers that run Linux, Windows, and then you can also have images that already have prepackaged software applications in it. So, Python, PHP, whatever it is. And so those containers are supported by Docker, which is really that platform for virtualizing within that virtual machine. So think of a container as it's a running, isolated application, and you might have multiple containers running on that same virtual machine, but they're all isolated, running in their own memory space and things like that.
And it's supposed to be more secure by being separate, right?
Yeah, I mean, that's part of it is you want to make sure that you are running those containers in isolation. There are overrides that you can do so that they can talk to each other and things like that, so you just got to be careful. But, and then lastly is AWS Lambda. So think of this as a function as a service. So I want to run some code. I just give Lambda the code, and it takes care of scaling that across multiple containers. I don't even know that it's containers into the scene. All I know is I'm basically running functions. So Lambda is something that we could probably spend a couple hours on, but I will demo it a little bit later as well. All right, so EC2. When it comes to EC2, you have a lot of choices. So you have the ability to run Linux, the ability to run Windows, ARM, x86 architectures, and then we have a gamut of workloads that are supported by the instance types that run underneath that. Even now I have the ability to do a bare metal image. You have the ability to hook up disk, do specific networking, cluster computing, things like that. You can also do your own custom machine images where you can take advantage of partner or community AMIs. And then you have multiple purchase options. I mentioned before, on-demand, reserved, and spot. You also have a choice of processors. So recently, for instance, we mainly ran Intel, we ran NVIDIA, or gave you NVIDIA options for GPU. We announced the ability to also run AMD, and typically that's at a reduced price. So again, we want to give you the option.
Typically that was what?
A reduced price. Yep. So you can look at, for instance, the instance types, and I'll go through it in a little bit, but if it has an A at the end of it, that's typically mean it's running with an AMD processor. Right. And as you see there, so a lot of options, a lot of capabilities, over 200 instance types, again, to support virtually every type of workload. Now, one of the things that's really cool is the innovation at the hypervisor level. So we announced this Nitro system a couple years ago, and basically we went from a hypervisor that was pretty standard. It was obviously customized based on our security and compliance capabilities, but we then started to push a lot of capabilities down into the hardware. And so this gives you more efficient, more secure, more optimized capabilities at the hypervisor level. Now, this isn't something that you necessarily have to worry about. I just know that it is there, and AWS continues to innovate in this fashion. And a lot of times moving to these instances as well was cheaper, so it made a lot of sense to take advantage of this. But as you can see here, we kind of broke this out into the Nitro card, which gave you the ability to hook up to disk drives, which we call elastic block storage. Nitro security chip, so this integrates a lot of the security features into the chip itself. And then the hypervisor, which is very lightweight, so giving you more efficiency and more optimization at the hypervisor level. And then a little bit more on that fully managed container environment. So for instance, like ECS and Fargate. So this is basically a container orchestration layer that AWS built from the ground up. But it gives you the ability to bring your existing container code it's production ready, meaning that not only can you scale to 10 or tens of thousands of containers, but it also supports typical compliance regulations around PCI, HIPAA, SOC, and so forth. And then it has integrations into the AWS ecosystem, like networking, disk drives, and so forth. And then we heard from customers that they like to run Kubernetes. Anyone here use Kubernetes? Got one back there? Okay. So Kubernetes is a container orchestration platform. It's open sourced. So you'll see it on a lot of different cloud providers. But AWS built it with the mind that we want to make sure that you can bring your existing code, that it is production ready, so that we have a fully managed cluster available to you to start to bring your containers to. And then also, same thing that we have with ECS, have those integrations into the AWS ecosystem. Right. And then kind of going down that path, that last path of compute. So this idea of serverless. Anyone here heard of serverless? Okay, cool. Anyone here use serverless technologies or build serverless applications? Do you think it's a pipe dream? Do you think you can do it? So we do have a lot of customers doing this, and actually it's one of the things that I love to do because I'm a developer at heart. So anytime I can pull away from like the infrastructure and the machines and the containers, it's great. But the idea here is you're basically using building blocks, using services that AWS manages. AWS handles the scaling, handles the redundancy. You also get pay per use. That's a huge thing. So you're actually only paying for the execution time or the amount of data that's being stored within that service. So if you look at serverless at scale, you have service fundamentals, but then you have new application patterns. And this is a lot of times where re-architecture comes in. But you can use things like SQS, which is our simple queue service. So if you just want to drop things into a queue, you create your queues, you can secure them. It has an API to drop into that. Not only that, it has listeners built in, so you can actually listen with like a Lambda function. So you can say, okay, when something drops into that queue, I want to run my Lambda function, which might be Node.js or Python or Java code that actually responds to it, takes it out of the queue, and then processes it. But this is the big thing, is empowering developers. So this is where I see a lot of agility, a lot of innovation with customers, is they can take a concept and prototype it out very quickly by putting these serverless building blocks together. And then eventually, if it goes well with the business, then actually productionalize it with the same serverless ecosystem.
So what's the real benefit there versus having your own instances with AWS server?
So let's take for instance a API. So if you're building an API, so you'll have, if you're building that on a server, you want to make sure that it scales. So as you get more users or more usage, you want the ability to grow your environment, so either vertically or horizontally. So with instances, you have to manage that. And we do have services that help with that called auto scaling. But the second thing is then you're paying a lot more as you scale it out, right? Because you have to add more instances and so forth. With the idea of using like Lambda as the back-end business logic, you're actually only paying for the execution time of that service. So the scalability is built right in, and most people see a huge cost reduction in moving that to like a Lambda and serverless environment. So I would say mainly it's scalability built into the service, because Lambda is actually, it takes advantage of our availability zones, so it has redundancy built into it. It also will scale automatically. I think by default you can have like up to 1,000 transactions per second, and then you can also, like if you need more, then you can request more. And then again, you're only paying for that execution time. It's actually billed at the 100 millisecond increment. And there's if you go online, you'll see a Lambda calculator, so you can actually calculate, okay, this is how many times I'm going to run this function in a month. And if you compare it typically to like an EC2 instance that you would build, it's I see like up to 70% cost savings on that.
Is there storage in that architecture? If I'm just paying for processing, what if I have to store stuff? Where does that get stored?
You'll use one of our storage services. And I'll go through storage and database later.
Okay, just want to make sure that it was an obviously missing piece.
So let me expand on this question, because that was where I was going to go too. I've got an API that hits a PostgreSQL database. And if I spin up this API as some kind of a Java app, let's say, that's on the serverless at scale, it still has to go hit my database server in order to service the API. So the only thing that's I hear that I'm scaling is that little Java instance building. I'm still going to have a PostgreSQL database somewhere on EC2 or something like that in order to build out this application like that.
Sure, you still need databases. That's not going away, but that business logic component is pretty important, right? Because that's actually what's serving your data to your end client. So that's just one piece. Once I get into the server, to the database and storage in the second session, I'll talk about things like auto-scaling your databases, and then also choosing the right database for the right job. Because I've been in companies where we standardized on SQL Server or Oracle or Postgres or whatever it may be, and so you try to fit everything into that relational database. With AWS, you have like 10 different database technologies that you can choose from. So you have Postgres, you have SQL Server, MySQL, all these, but then you also have like key value storage. So if you're just storing key value pairs, you might use something like DynamoDB, and that has auto-scaling built into it, completely managed as a serverless environment.
Back to the serverless thing for just a second, because I've been seeing a lot about this and trying to get my arms around how it really fits in to the infrastructure that my folks are using. And again, the only thing that I see that it's bringing to the table is that instantaneous scalability of the Java component that's running as a listener, if you will, to the things that are being dropped in from a queue. I get that. I got this massive queue, I'm dropping requests into that queue. The listener funnels that off to some Java app. The Java app and the queue, I think, all fit into this serverless model. But at that point, everything else is then still using a traditional type of infrastructure for the data storage, which is like where he was going. Am I wrong in that or not?
That's one model. We actually have like a lot of serverless reference architectures. Let's give you some examples real quick. Wasn't prepared for this necessarily, but this is one that's out there. So in this case, you're looking at all serverless. So you have this concept of an API gateway. So like if you were spinning this up on an EC2 instance, you're gonna have to manage security, you're gonna have to manage throttling, you're gonna have to manage access keys, you're gonna have to manage caching if you want to do caching. All that's built into that API gateway. So it becomes, again, a managed service that kind of does that all for you, and you have knobs and configuration that you can put in there. And then typically, like even if you have an EC2 instance behind that gateway, this API gateway here will often like take a lot of load off of that because it's doing things like caching, it's doing the authorization. And then you have Lambda here, and again, so that's spinning up Lambda functions based on demand. So as your capacity grows, you get more executions, it's automatically scaling that in and out. And you're only paying for the execution. So if you did an EC2 instance, you're paying a set price for that EC2 instance to always be there, even if it's not running. And then you have to pay, for horizontal or vertically scaling as you get more transactions. So I think you get that, but that is a huge cost savings for customers that are running, hundreds, thousands of APIs, or just want to be agile and be able to spin up these these functions really quickly without having to worry about the underlying infrastructure. And then back here, like you see, this is actually DynamoDB, which is a key value store. So that's not to say that that's going to be the right solution for everything. I mean, we still have...
That could be any database.
Yeah, but DynamoDB is one that's serverless. So you have, again, bells or knobs and levers you can turn, but it auto-scales it and it grows your throughput based on demand. I will touch on, too, we have a database technology called Aurora, which is MySQL and Postgres compatible. I'll touch on that in the second session, but it also has a serverless capability to it as well, which kind of blows people's minds that this is a serverless database. I'll tell you how that works in the second session. Does that help? Yeah. But you're right, you still need data, you still need storage. But what I want to get to later is that you have a lot of different choices. Yeah, questions?
Well, some of your previous slides say you've got stuff that aren't HIPAA compliant, PCI compliant, but before, a few years back, they could do it for you, but it would take lots of setup. You got that kind of more templates now that you can work that for the compliance issue?
Yeah, so let me bring up another site here. So the one place I always point people to, because there's a lot of different security frameworks and compliance frameworks, is our compliance website. And so that goes through all the different compliance programs. And you can break that out by healthcare, financial services, and so forth. So like if you wanted to go into, we'll say healthcare, well, let's talk about the case study, but let's go specific. I'll just search for HIPAA AWS compliance. Yeah, so this is an overview. The frequently accessed question, or the frequently answered questions, huge help because it talks about HIPAA. It talks about this idea of a business associated addendum, a BAA, how you go about procuring that with AWS. That is important because we have this concept of HIPAA eligible services. So these are services that do fall under the BAA compliance with AWS. And so all the core services are going to be there. And I think we have, now we're like 60 of our services that are HIPAA eligible. And then, that's something that, typically you can either negotiate with AWS or you can just use the BAA that we have that you can access through the AWS console as well. So that's all laid out. And then we have like quick starts as well. Quick starts build out a reference architecture. But I mentioned like that shared responsibility model. So, we control hypervisor down and then, you control above that. So it's still up to the customer, up to you guys to actually put all those in place, whether it's encryption at rest, encryption at transit, and so forth. Where we at with pizza and time? Okay, I'll keep going.
Go through you, smell it.
All right, sounds good.
We don't show up.
All right, so I'm going to stop this session and then go to the other session, just so we can go a little bit deeper into the things that we talked about, like compute and storage and database. But again, if you have other questions, just let me know. And I should be able to post all these slides. Do you guys have a place where I can post these? Yeah. Okay. So I can post all these slides so you can take a look at them later.
That'd be great.
All right, so this is AWS 101. So this is kind of the core services overview, how to get started. I'll bring up the AWS console and go through a few of the demos. But what we're going to look at is compute and EC2, networking, security, storage, database, and analytics. May not get through all of it, but I do want to try to at least get to the storage and database part. So I may fly through a little bit of this, but again, at any time, just stop me and ask questions. Okay, so already, just to kind of reiterate, you have a lot of choices for compute. And we're going to talk, kind of dig into Amazon EC2 here. I already talked about, those broad choices you have around operating system, machine images, and things like that, but I want to go a little deeper into some of the terminology. So EC2 always starts with what we call an AMI, which is an Amazon machine image. So this is really your virtual machine configuration. So this is, what operating system is, it's attached, it has a boot volume attached to it where your OS is stored and things like that. So your AWS instances, which is your running or your stocked virtual machines, are actually launched from that AMI. We have AMIs that we make available for Windows all the way, as recently as the Server 2019, and then Linux, including Red Hat, Ubuntu, SUSE, and so forth. When that EC2 instance is launched, it's launched into a VPC, which is a virtual private cloud. So a virtual private cloud, I'll touch on a little bit more in depth, but just think of that as a networking environment within AWS. And that virtual private cloud is part of a region. And you actually launch that into what we call a subnet within an availability zone within AWS. And then you can launch multiple instances, obviously, across availability zones so that you get high availability for your application. And then when you launch that instance, you can also attach disk drives, quote unquote disk drives. These are something we call elastic block storage. So it's block storage, so it's formatted disk, and you can attach multiple volumes to that EC2 instance. And you can scale those EBS volumes for as little or as big as you need. And then you can back up those disk drives. You can back up those EBS volumes with what we call Ebs Snapshots. The snapshots you see here are actually stored in Amazon S3. What's big about that is you get the durability of Amazon S3. So as I mentioned earlier, that's a service that actually replicates your data across 3 availability zones within a region. So the snapshots automatically get that durability of Amazon S3. A little bit about the EC2 naming, because I mentioned we have like over 200 instance types now, so there's a lot to choose from. With that comes some skill set that you need to know in tracking down what all these numbers mean. This first one is the instance family. So this is really the workload or the purpose of that instance. So in this case, a C means compute optimized. So it's going to weigh heavier on the virtual CPU side. We also have R, which is memory optimized. With general purpose, which is the M family. But you'll see M, you'll see T, you'll see X. All these have a certain purpose. The instance generation is a number that we assign to the generation. So as we come out with new instance generations that are optimized and improved, they'll have a higher number. And then typically we fade out those older generations. And then an attribute is something special about that specific instance type. If it doesn't have an attribute, then it's, there's nothing special about it, but if it does, like N, this has enhanced networking, so it's like up to 100 gig networking capabilities. If you see an A, that's the AMD processor, so that's specifying that it's running on an AMD processor. And then the instance size is kind of a t-shirt size of the number of virtual CPUs and the amount of memory that are in the instance type.
And typical amount of storage, right?
What's that?
And the typical amount of base storage in that last parameter. I know in the Windows servers that I was spinning up, depending on what I picked there, I got a different amount of storage to start with.
Yeah. So when you go through the launching of an instance, based on the AMI, it'll give you a default number. You can actually change that.
Right.
But yeah, like I think Windows, it does like 30 gig. Most of the Linux, it'll do like 8 gig.
Right.
But that's something that you can change.
Right. But depending on what size that pick, that starting size is also affected.
Yeah, that may be. But again, it's configurable because the block storage is actually it can be it's basically a separate component from EC2 from the compute. Yeah, question.
Are community AMIs, are they supposed to adhere to this naming scheme, or like how can you tell what somebody else has put on their instance when they open it?
Well, remember the AMI is really the operating system, and then you can the community AMIs may package it with additional software. So it's basically the boot volume for that instance. But you can spin up an AMI and choose a different instance type every time. There are some AMIs where they'll restrict the instance type that you can run that on, and that's typically based on minimum requirements.
Jason?
Yeah.
Pizza's here.
Pizza's here.
Let me just ask everybody when you go through the line, first time through, please limit yourself to 2 pieces. I want to make sure we have enough for everybody after everybody's been served.
Compute storage. So I'm just going to choose maybe a 2-core 8 gig machine and then configure my instance details. All right, so this is where we get into you can launch multiple instances at once. So let's say you're launching a website where you want to load balance across multiple instances. You can do that. Or you have a cluster, like a cluster that you're running, you can do that as well. And then you launch that into a network. So I'm going to stop there and talk about networking. This is a real cool graphic showing kind of the spectrum of instance types. So you'll have that in the slide deck. But it shows, each of the workloads that each of those different instance types support. Before we get into networking too, I just wanted to mention that a lot of people will kind of layer how they purchase their EC2 instances. So they'll have like a baseline metric that shows, and this typically will be based on the amount of traffic maybe that they typically get for their website. But they'll have these maybe peaks and valleys where they get a spike in traffic either based on the season or the day or the month or whatever. So they kind of layer it. They purchase like reserved instances so they get that reduced pricing discount for that baseline, and then they'll layer on demand using auto scaling. So that's really a good way to optimize your cost over time. Reserved instances, what's cool about them is like if I purchase a reserved instance, I choose the instance type that I want to reserve, but it's not tied to a specific instance. It's just tied to that instance type. So that doesn't mean that if I stop an instance and start a new one that I have to purchase a new RI, as long as it's that same instance type, that billing discount applies. All right, so I'm going to go through, I already touched on this, so I talked about our new Nitro Hypervisor, so I'll go through that really quickly, but I want to get into networking. Because you have to use a network in AWS. You have to launch your EC2 instances into a network. So this is the technology that we're going to talk about. So the first thing is Vpc, which is Virtual Private Cloud. So think of this as a logically isolated section of AWS. It's bringing your own network. So you bring your IP address range. That IP address range is an RFC 1918 private IP address range. So you can choose up to as large as a /16, which for those who don't know, that's about 65,000 IP addresses. And then you break that network up into subnets, and then you route the traffic through routing tables. Think of a routing table as a virtual router. So it's a mini router that you can basically spin up within your networking environment, and then basically tell the AWS network where you want that data, that traffic to be routed. So when you bring your own network, you basically create a VPC. That VPC is across your entire region, so across the entire region. So it spans all the availability zones. But then you can break up that VPC into what we call subnets. So a subnet is a smaller section of that VPC. So in the case of, let's say we had a VPC with maybe a 10.0/24 cyber range, I can then break this up maybe into /27 and /27, and then they can talk to each other, but the nice thing is that they're in different availability zones, so I get high availability. So if I'm going to the website, I might put load balance servers across the AZs, so that if this AZ ever had a major issue, whether it's power or networking or something like that, this one is unaffected, and you still run your traffic to that other availability zone. But it is important to think about planning your IP space before creating it. You cannot change the IP CIDR range once you create a VPC. You can add additional CIDR ranges, but you can't change it. So that is important to know. Why this is important, if you ever want your VPCs to talk to each other, overlapping IP address space does not work very well. You get into like overlay networks and things like that, and it's something you want to avoid. So you just want to plan this out. A lot of customers will have a template, or they'll use what we call a CloudFormation template to actually spin up these VPCs so that it's done in an automated but also a governed fashion. And they might use like an IPAM solution or something to pull a block of IP address ranges.
When you talk about, are those private IP addresses you're referring to, or?
Yes. Yeah. They're private. So anything that I talk about in a VPC is private IP address ranges. I won't talk a lot about public, but they're available there as well. So you can actually optionally assign a public IP address to any of your EC2 instances. You can also reserve public IP address space using what we call elastic IPs. And then we also, I think it was about a year ago, we announced the ability to bring your own IP, like public IP space, and use that within AWS as well. Yeah.
You said that the CIDR can't be modified until you add to it, or add another one.
You can add another one, yes.
Can I take one out?
No.
No, once it's there, it's there.
It's there, it's there. Yeah. So in the case where you would need to change it, you would create another VPC and then migrate all your resources to it. But that is, it's not a push button, I'll just say that. So there's some work involved in that.
Painfully aware.
Yeah. Okay. All right. Routing rules, so this is done through the route tables. So I mentioned that before. So this is basically how you can direct traffic outside of your VPC. So in this case, we have a public subnet, a private subnet, and then maybe we want to peer that with another VPC. So you can set up routing rules to tell that traffic where to go. Or you maybe want to bring that back to your corporate data center over like a VPN connection. It says public and private. You can name these whatever you want. It's just a tag. What signifies public subnet typically is if it has an internet gateway attached to it. So it has a route to the internet. What most people do in a secured environment is the public subnet will hold like load balancers, proxies, NAT gateways, things like that, because they don't want to expose the actual instances to the outside. So the private subnet is where you would have like your application, web servers, and databases. We do have a managed VPN appliance. So this basically is the AWS side of the VPN connection. And we call it a virtual private gateway. And then your customer gateway is going to be your own device, whether it's a Cisco or something like, or a Palo or something like that. So that gives you a IPsec tunnel going across the public internet. But it's a great way to get started for a secure connection from AWS back to your on-prem data center. I don't have a slide for it, but we announced what we call a transit gateway. So this, once you get more mature in AWS and you have like a lot of VPCs and accounts, you don't want to set up a VPN connection for every VPC. So the transit gateway is a way that you can basically centralize that VPN connection in one account and then share it out to all your other spoke VPCs. It supports transitive routing, whereas we have another service or feature called VPC peering, which does not. It's just one-to-one VPC peering. But the transit gateway is a solution that you can use to centralize your networking between all your VPCs and your on-prem data center. And then as you get more mature, you may look into like direct connect. So this is a dedicated circuit that you typically will get through your internet providers to one of our direct connect locations. We have direct connect locations around the globe, and then it's a cross connect over into your VPC. And that supports up to 10 gig connections, and then you can also do link aggregation, so you can support up to 40 gig connections.
It's some sort of point-to-point connection,
Yeah. It's dedicated, which is going to give you lower latency because you're not going over the public internet, and higher bandwidth. And then anytime you see the word gateway, just think of that as basically you're connecting outside of the VPC. So we talked about the virtual private gateway, but we also have internet gateway, which is basically a device that gets attached to your VPC. Now this is a virtual device, and then it scales automatically for you. So it basically shows up as a virtual device within your networking component within AWS. So let me show you that quickly. So this is the VPC service. You'll see over here, I have all my VPCs listed, the subnets, route tables, and then I have internet gateways. So if you want to create an internet gateway, it's just as simple as clicking create internet gateway. You can tag it, things like that. But that basically you can only have that internet gateway attached to one VPC. So that's why you see multiple ones here. But typically you just have the amount of internet gateways that you need to actually communicate publicly. If all your data is private within AWS or going over VPN, then typically you don't need an internet gateway. Nobody's asked about pricing, like how much does all this cost, right? So,
How much does all this cost?
Okay, great question. So, as I mentioned, all the services and features basically pay for what you use. We have this tool called the Simple Monthly Calculator. Has anyone ever used that? Try it. It's simple. It's so simple.
You said your one client had a $40,000 a month bill and we dropped it down to $4.
Right.
It's still a lot of money.
So this is a way that you can estimate out a monthly bill. Now it's an estimate. There's a lot of there's a lot of things that you have to think about. You have to think about obviously the compute, storage, database, but you also have to think about do I need an internet gateway? And if I do, then how much is that going to be? So we have over here on the left-hand side, VPC. There we go. So we have Amazon VPC. So if you needed a VPN connection and that gateway and so forth, you can estimate that here. Internet gateway internet gateway's in here somewhere. So, but basically, this is a way that you can estimate your costs. So you can go in here. Yes, it's simple, and you can say, okay, I need 2 web servers. And you can also specify the usage. So maybe it's something where it's a test environment. You're going to use it for 8 hours a day. So you can actually say, I'm going to use that for 8 hours a day. And then you choose the instance type. And then you can also choose the billing option as well. So in this case, I have a T3 2XL. But maybe I'm like, this is a test environment. I don't need that much. So I can scale that down to maybe a T3 medium. And I'll be like, well, I could save a little money here by using AMD versus Intel processors. So it shows you the on-demand price here. and then it'll give you an estimate of your monthly bill. So for these 2 instances, 8 hours a day on T3A medium, $18 a month. And then if you're like, well, I'm going to use these, all the time, then you can actually look at how choosing a reserved instance would lower your effective monthly cost for your services. So again, so if you're looking for pricing, this is you can go to each service pricing page and it'll have the on-demand rates, it'll have the reserved instance pricing, but this calculator helps you kind of estimate it out without having to do your own calculators.
When somebody creates a system, say 2 CPUs, now say blows it away, he needs 3, or the other, he has 3 and he's only used 1. Is it up to the customer to figure out what he needs, or do you guys get hints that you name the annual CPUs or just the amount of CPUs?
Yeah, we have a service called Trusted Advisor.
Okay.
So within your account, there's a service. You just go to Trusted Advisor.
I'm setting this up as somewhat of a guesstimate. Right. I guess right.
So this will actually, it has 5 pillars. So it'll look at cost, performance, security, fault tolerance, and service limits. So if you want to look at, okay, how could I save money? And so this is typically where it's going to show you maybe instances that are idle. So in this case, it's saying you have an Amazon RDS database instance that's idle. And then it'll give you also recommendations for like where you might want to purchase reserved instances and things like that. So it's a nice tool. I will say that a lot of people look at it and there may be details specific to the workload where they don't follow the exact advice, but it is there. As well, we have CloudWatch, which captures the metrics on, for instance, CPU, so you can actually monitor, and you can set up the alerts as well. So you can set up alerts on your EC2 instances to where if they drop above or below threshold, it'll alert you, and then you can take action. Okay, so that was just showing you the console where you can find the VPCs, internet gateways, and so forth. So in this case, this is just showing you that an internet gateway is required, obviously, for accessing the internet to and from your VPC. And in this case, this is using an elastic IP, which is a public IP address, which is then assigned, typically will be assigned either to a load balancer or to an EC2 instance. Now, in the case where you don't want to give internet access to your EC2 instances, but you want them to be able to communicate to the internet to do like downloads and patches and things like that, we have a NAT gateway. So this is a managed virtual appliance as well. That basically sits in your public subnet and controls the basically proxies traffic out to the internet for your EC2 instances. And again, the nice thing with the NAT gateway is it's completely managed. It scales automatically for you based on the traffic that it receives. Supports up to 10 gig bandwidth. Supports the common protocols TCP, UDP, ICMP. And you can also control access through what we call network ACLs. So these are access control lists, the rules that you can put on your subnets. A little bit about VPC End Points. This is not something you're gonna, like, if you spun up an AWS account tomorrow, you probably wouldn't use tomorrow necessarily, but you need to know that they're there because they're a security control. So we have our VPC over here. That's where we're running our EC2 instances. That's where we're running our databases, things like that. AWS also has these managed services. So I talked about a few of these, like Amazon S3. Amazon S3 is a managed service across the entire region. So it's an object store. We take care of the scaling, the replication, everything like that. What that means is it doesn't run inside your VPC. It's a completely managed service out here. It's accessible publicly, so we have public endpoints where the APIs are actually called. But you can control it so that no one can access your S3 containers from the internet. They can only access them through the VPC. And the way you do that is through Vpc End Points. So this is a private connection that you can set up between your VPC and the AWS service. And so we have this for most of our common services, S3, Dynamo, API Gateway, and so forth. And I mentioned a few times VPC peering. So if you have two VPCs, you can peer them across accounts, even across regions. So this is really cool. So like if you, maybe you have data that for whatever reason, maybe you have a user base there, maybe you have data in Ireland, in that region, you can actually peer that VPC to an AWS region in the US. And then you get that private connectivity. You just set up your routing rules between the VPCs. And you don't have to worry about that traffic traversing the internet. It goes over the AWS global backbone. All right, and then if you're hosting websites, if you're hosting APIs on EC2, you want to set up a load balancer. So we have managed devices for load balancing. We have really two types of load balancers. We used to have one called a classic, we now call it the classic load balancer. It was basically used for both layer 4 and layer 7. We've now broken that out, so we have an application load balancer. It's used for layer 7 routing. The nice thing with this, you can do content-based routing, so you can do, if you've ever used like an F5 or something like that, very similar capabilities. So you can do path-based, you can do domain-based routing. So you can basically set up rules on your load balancer to route to different backends. Then we have a network load balancer, which is meant for high throughput, low latency applications. It supports only layer 4 load balancing. We can do things like static, elastic IPs. It can also be used for long-lived connections, like you're going to WebSockets and things like that. So network load balancer would be more if you're maybe load balancing a compute cluster, or even databases in some case, like for read replicas and things like that. And so this is a nice chart to just tell you the difference between the two. Route 53. Route 50 DNS service. DNS registration, so you can register a domain name. You can do private domains and things like that. But you can also do global traffic. Create rules for routing traffic between maybe different load balancers, and you can do things like A/B testing over websites, so that if your main application site's down, it'll automatically fail over. So it supports like global health checks and things like that, as well as like geographic-based routing. So it'll route maybe to a different application site based on where the user's coming from. So again, you can do domain registration. It'll do health checks, DNS failover, latency, geo, and weighted load balancing. And then you can also do private DNS just for your VPC. So rather than reference your EC2 instances by IP address, you can create your own private IP address or reference the traffic within your VPCs that way. So going back now, let's assume I've created a VPC. So I have a VPC here, and I'll choose a subnet. Now you could choose no preference, and it'll just choose one of the subnets within your availability within your VPC, or you can specify. So in this case, maybe I want to put this into a private subnet. And in this case, I don't want a private IP because it's in a private subnet. So now, even if I chose enable, the fact that this is not attached to an internet gateway, the subnet's not routing to an internet gateway, it won't be accessible outside my VPC through that public IP. But if I chose one of my public subnets, then it would. And I'm not going to go all the way through this, but some other things I want to mention. IAM roles. This is really cool because you can basically give this EC2 instance access to other AWS services by using what we call a role. So basically that EC2 instance. So let's say you wanted to communicate with Amazon S3 to write data to and read data from. You basically set up a role that has certain permissions to that S3 location. And then automatically any SDK, any API that you call through AWS will automatically have access to it. And then AWS uses what we call access keys and secret keys to basically do that communication with other AWS services. And it will actually rotate those credentials on a fairly frequent basis, so that you don't have to worry about rotating and storing credentials within your application. All right, and then so after that, then you add storage. Kind of skip that. So it gives you the root drive by default. You can change that. You can add additional data volumes if you want to. This delete on termination is important because when you delete an EC2 instance, the EBS volume is basically a separate entity from the EC2 instance. It's attached to it, but it's separate. So its life cycle, its lifetime can span well beyond your EC2 instance. So what you'll notice here, if I add a new data volume, that flag's not checked. The assumption here is that if you have data volumes, you're going to want to keep those potentially around longer than the EC2 instance. The root volume you probably want deleted when the EC2 instance is deleted. But just know that you can change those. You can have them, none of them deleted or automatically deleted.
If you don't delete it, can you get back to it?
Yes. Yep. So under the EC2 service,
Whatever, attaching to a new instance.
you can also attach it to a new instance. Yep. It can only be attached to one instance at a time, but you can change which ones it's attached to. So you'll see on the left-hand side here your volumes. So these are all the volumes that I have, and it'll tell you if it's in use or if it's available. So if it's available, then I'm basically able to go up here and attach that volume to one of my EC2 instances. So a little bit about the cost model here. So EC2 instances, you're charged during the time that it's in a running state. So if we go back up here to EC2 instance, you'll see here that I have 2 that are running, but I have many that are stopped. So I'm not being charged for those EC2 instances when they're in a stop state. But we keep all the metadata around, so if you want to just restart it, you just go up here, choose it, and then click Actions and Start. Once you click Terminate, that's it. It's gone. So you just want to make sure that when you terminate, that you have backups of any of the data or the drives that are attached to it, especially if you have that delete on termination flag set.
How are you backing them up?
Backing up.
Your virtual drive, I mean, are you taking a copy of that image and putting it on your S2 or your S3?
Yeah, so your volumes, you're in control of the backups. So that's where the snapshots come into play. So the snapshot is basically a backup of that drive, a point-in-time backup of that drive. And you control that. But we have a service called Lifecycle Manager that will basically allow you to create a snapshot policy. So you can, and the nice thing is you can use like tagging. So you can say my production volumes, I'm going to back those up daily. My test and dev, I may only back up weekly or monthly. So you can use this lifecycle manager to not only tell it to when to back up, but also when to remove old backups as well.
So you can have I've got 8 in my queue or 3 or whatever. And are you paying for less because you're using less storage, or are those snapshots
so it's
like deltas?
Yeah, so snapshots are deltas. So you're only paying for basically the changes. I think the snapshots are charged like 5 cents per gigabyte. So you would have that initial snapshot being basically the amount of data that you're using, and then only the deltas for subsequent.
Traditional.
Yep.
Like 5 minutes.
5 minutes?
Yeah,
No one wants to stay till midnight?
that's why I stayed till midnight
Wow.
in the parking lot.
All right. So we didn't get to security. We didn't get to really didn't get to a deep dive. We touched a little bit on storage and database. But let me ask you guys, anything that you want to know about in the last 5 minutes?
Do you want to cover the cost if they lost the data and they had to go to the to bring it back home?
Yeah, so I think you mentioned that during break. So the question was, and I'm assuming that's like a backup use case, right?
Well, say that there's a tornado and wiped out everything on the ground. How would they get the data back to the ground?
Okay, so you're storing it on-prem and AWS? Or?
Either.
Okay, let's go this way. So I think the question is, what's the cost to bring data out of AWS? So there's data transfer costs, so that's one thing to be aware of. And that's something that you can map out through the simple monthly calculator. That's basically down here, the data transfer. So anytime you bring data into AWS, it's free, there's no charge. Anytime you take data out, there's a data egress charge. It's 9 cents per gigabyte, that's what it starts at for in and out. But if you use like Direct Connect, that's actually, it's about 1/4 of the cost of that, so roughly around 2.5 cents. So you do get that, that cost savings if you're using Direct Connect.
Can you do that with an AMI? Let me give you a specific case. I've got a company that I'm working with that's mothballed. They've still got a couple of AMIs laying there that they're paying for storage on, only in case they ever need to spin them back up. Ideally, they'd like to pull that offline and store it somewhere on their own ground, and then later, if they need it, bring it back. But so far, I haven't seen anything for doing that. I've seen plenty of it for moving data, but not for AMI.
Yeah, the AMI is really a AWS template, so it won't work on any other, any other hypervisor.
One doesn't work on any other stuff. I bring it back to there.
Oh, okay, you just want to hit it.
I don't want to pay for the storage, because it can be 3-4 years from now before they ever decide they want to spin it back up.
Well, remember, the storage is actually the EBS volume. So the EBS volume, you can bring back on-prem. Now, it's not like just I want to download this. Yeah, there's a couple ways to do it. So you can either set up like a VPN so that you can communicate with an EC2 instance that's basically has it mounted and then pull the data down. But you can also, we have a product.
The data is not the issue. I've got the data. It's the instance and the setup of the server itself. The Windows server, with a database server on it, and Servoy processor running, a whole bunch of other stuff. And they'd like to be able to capture that.
The C drive.
Yeah, the C drive. Yeah, basically, it's the C drive. Store that away, and then if they ever need to spin it back up for whatever reason, load it back on Amazon and spin it back up. Because right now, to keep it, they're paying like $20 a month or something every month.
Yeah,
They've got several.
Yeah, let's talk offline.
Okay,
Yeah,
fine.
because there's a couple services that I think might help with that.
Can you
let's talk
archive that on S3?
What's that?
Archive those volumes on S3?
Well, remember the EBS snapshots, those are automatically, those are backed by Amazon S3.
Well,
So they show up in your account as EBS snapshots, but it's S3 that's actually backed.
can you just download it from an S3 connector to a local server?
Yeah, I think, and that's why I wanted to talk offline, because I want to talk a little bit about the use case there. Yeah. I think there's several ways you can do it.
What is the closest location of the data center to the home?
So we have a region in Columbus
Okay.
called US East 2.
Okay, what
Ohio
if
region.
Columbus had a tornado? What would happen? The whole thing is lost.
So again, the regions are built with redundancy in mind within that regional ecosystem. And then you have the option of transferring that data to other regions, either through, you can send your snapshots to other regions, you can send your CloudFormation templates, which is basically a template of your infrastructure. You can send your S3 data. You can basically replicate that to all your other regions.
But you have to do that before a tornado.
Yeah, we don't, because of that data sovereignty, we don't automatically send your data to other regions. So yeah, you have to think about your DR strategy and how much risk you want to accept. I mean, what are the odds of all 3 availability zones in Columbus going down. You can calculate those, I guess.
You're saying you do replicate across all 3 zones?
Yes.
So that means like 3 data centers in Columbus, or one in Cleveland, one in Columbus, one in Cincinnati?
They're all in the Columbus area.
Thank you.
But remember, an availability zone is like a collection of data centers.
They're in secret locations in tornado-proof buildings.
They are secret, yes.
Yes, but are they earthquake?
Earthquake.
They're all fault lines.
We have a website where you can take a virtual tour of the data center and get more information on how it's built, all the redundancies that are in place.
You can't see it outside of them.
Can you give us more details on how we can see you every other Tuesday and where that's at?
So
For
it is,
people that would like to.
yeah. So it's at Max Training in Mason.
So Tech Lloyd.
Yeah. If you go to there's a website actually. I have it here.
Everybody here knows we're not playing. We have a meeting here.
Okay, great.
So,
He doesn't know. He doesn't know.
it's new people.
He doesn't know.
If you go to Meetup
You have a link
pull
off the
Tech
main
Lloyd,
website.
Yes.
I don't
but these
remember.
people have never done it, they don't know where to run.
Yeah. So if you go to meetup.com/techlife-Cincinnati and just search for Amazon Web Services, you should see my face. And I don't know if we have the August one posted yet. We usually post it about a week and a half in advance with all the topics. But the next one is August 27th.
And my last question is, you wanted to brush path certification with us?
Yes. So we have a training and certification website. This will take you through all the different certifications that are available. If you specifically want certifications, just go right to the certification page and it'll tell you the different certifications that you can get. Usually starts like with cloud practitioner, which even a lot of non-technical people will typically take, just so they get an overview of the terminology. And then building on top of that is the associate exams, and so that includes architect, operations, and developer. And then the professional exams are available for solutions architect and DevOps engineer. I have all 5 of those. Professional one by far is the most grueling. I was kind of freaking out about it, but I passed. And then over here we have specialty exams. So like if your main thing is I just want to know about security, I think you still have to have one of the associates to take that, but you can take like the security specialty exam.
So does Amazon provide those classes, or do you have to go to like Max Train or something like that?
You can check. I don't know if Max Trains has any of those classes.
Can you just study yourself?
But you can.
Practitioners online.
Yeah. But you can go in here and see which ones are available. And then there's an AWS.training site. I believe that will show you all the options you have for this in-person classes.
Online training is super. I went through this basics. It's done super. So whoever wants to try foundational certification, I highly recommend just don't buy it, go online, get it, and if you listen to all of this, you don't get it. Plus it's your
Is there a cost to start?
It's free.
Oh, it's free.
There's 2 online training sites that I recommend, either A Cloud Guru which I mentioned earlier. They mainly focus just on AWS certifications, but I use Linux Academy. So it supports really all the clouds, but it also supports like just skill sets in general. So like someone had asked about Docker, and if you don't know about Docker, they have some great courses like just getting started with Docker. I don't know, I forget what the fee is. It's maybe $20 a month, or you can buy it for the whole year.
What are the names of those again?
What's that?
What are the names of those again?
A Cloud Guru and Linux Academy.
All of those, I think it's 3 courses as well, but good ones.
So Linux Academy is the one I use to study for my certifications.
So I've already done 8 courses today, as well, the courses, including AWS, yes.
All right. Well, thank you for your time.
Thank you.
Thank you, Jay.